So we're going to take a look at the vertex form of the quadratic equation in a little more depth. We've been talking about A, H, and K, and so we're just going to continue with that. So just to recall, there is the standard form, which is just a standard trinomial. A x squared plus bx plus c. Remember, A in any case is always going to be a number other than 0. So that first there, that's our standard form of the quadratic equation. Our factored form or zeros form is a and then in brackets x minus r and in brackets x minus t. So that will give us the zeros of the equation, which we'll talk about in another lesson. But it's just our factored version of our trinomial above. And then in this case here, we're working with what's called the vertex form. And so this one allows us to take a look at the equation and find the vertex of the parabola simply by taking the h and k and plopping them into a set of brackets. So this is our x value h and our k is our y value. Note that it's negative h here, so when it comes out it actually flips the h. So if I come over here to the example, I have this standard graph y equals x squared, and then I have my shifted graph y equals ax squared plus k. The negative h goes over to positive h on the axis here. So negative h moves over to the right, where positive h would move over to the left. So the negative h, hk, that's our vertex, and then we have our graph that's opening upwards here. So this a value must be positive, and it probably is a narrower graph because, or a number greater than 1 because it's a narrower graph as compared to this one. And again, remember, if a is greater than 0, it opens up. If a is less than 0, it opens down. And then that absolute value of a, which is just dropping the negative sign, if it's a number bigger than 1, it stretches the graph. If it's less than 1, it compresses the graph. So let's take a look at applying some of this into some questions. So just straightforward, taking a look at our examples and seeing what's going on here. So we got y equals 3x times, 3 times x minus 4 squared plus 3. And we want to find in each case the vertex, axis of symmetry, the stretch or compression of the graph, the sketch of the parabola, the number of zeros, and the possible x and y values. So first off, our vertex is at 4, 3. Again, remembering that that negative 4 becomes positive outside of the brackets. In the second part there, the axis of symmetry, that's that line that divides the parabola directly in half. So if I go back here, our axis of symmetry would run right down here, and it would be x equals, clean that up, x equals, and then whatever the h value is. So y equals, x equals the h. So going back over to our question, the axis of symmetry in this case is x equals 4. And next we want to find the stretch or compression. So this is the vertical stretch or compression. And in our case, we have a 3 that is greater than 1. So it's greater than 1. So it is going to stretch the graph. So it's going to stretch by 3. We want to do a sketch of the parabola now. So if we do a quick little sketch of the parabola, I'll just draw a quick set of axes here. So my vertex is at 4, 3. So if I just kind of make some quick markings here, it's just a sketch, doesn't have to be exact. Here at 4 and 3, it's going to open upwards because this 3 is positive, and it's going to be a little narrower. So something maybe like this, with our vertex at 4, 3. That would be a quick little sketch of that parabola. And then our axis of symmetry would actually be here, and that is x equals 4 being the equation of the axis of symmetry. So that is the sketch. And then looking at our graph, it doesn't touch the x-axis, so in this case there are no zeros. There are no x-intercepts. Let me slide that up so you can see. And then finally, the possible values of x and y. So x, well, this graph would continue on forever and ever and ever this way, as would continue on forever and ever this way. So these directions along the horizontal axis, you could put any value for x and the equation works. However, y not so. Y is only greater than 3. So x is any real number, and an abbreviation for this is an R, kind of like that. So it kind of looks like an R with a little extension on it. And then y has to be greater than or equal to 3. So those are the values that y can take. In a realistic situation, like say we were using this to measure the height of a ball after throwing it up in the air, then x would might be limited because we would say if the x-axis was time, then x would be greater than 0 in a realistic situation, because it's limited by the actual imposition of the real-world situation. But in our case here, when we're just given an equation with no restriction, no situation, x can be any real number. So unless there's a real-world situation that prevents x from being a specific set of numbers, then you can always just say x is any real number. So looking at the next one here, we have y equals negative 8 times x plus 2 squared minus 4. So our vertex here, negative 2, negative 4. Again, that sign inside the bracket switches when it comes out. Our axis of symmetry is x equals negative 2. We are stretching the graph again. Negative 8, the absolute value, the 8 itself, is still bigger. So this is a stretch by a factor of 8. I'm going to do a sketch of this guy. And again, these are sketches. When we're asked to sketch, it doesn't have to be perfect. It just has to be something that will allow us to understand what's going on. So our vertex is at negative 2, negative 4. So it would be something like maybe right here, and then equivalently would be down here. So maybe here. And now it's negative 8. So that means this graph is going to open down, and it's also 8, so it's going to be pretty narrow. So I'm going to give a fairly narrow looking graph here. So there's my sketch of my graph. I probably could have shifted my axes over, but this works for what we're doing. So negative 8, negative 4, or sorry, negative 2, negative 4 is our vertex, and then our factor of negative 8 for the stretch. And then our axis of symmetry again would be here at negative 2. The next part, for the number of zeros, again, we have no zeros in this case. And then part 6 here. X, again, has no restrictions on it, so x can be any real number, or we can use the belong to sign. Belongs to the real numbers is another way of writing that. Your textbook doesn't use that, but in later years you might actually see this one used. So x is any real number, so that's an abbreviation for writing that again. And then our y value, y is less than -4 or equal to. So y is less than or equal to -4. So if it's opening down, y is going to be less than. If it's opening up, y is going to be greater than or equal to in both cases. So 2 more examples of this type of question here. So again, looking for the vertex of this equation. So the vertex of y equals 2x minus 3 all squared. The y value here, we could just put a +0 if we needed to. So it's just the h that is shifted. So we have a +3 and 0. Right? So we could put the +0 there. We don't have to put the +0 there. It just is taken for granted that it's there. Our axis of symmetry, x equals +3. What are we doing next? Next is stretch or compression. And again, we're looking at a stretch of 2. Then a sketch of the parabola. So we have -3 and or +3 and 0 as our vertex. So over here somewhere at 3. So this is 3 and 0. And then we're opening in an upwards direction because this a value is positive and it's a little narrower than our usual graph, something maybe like this. And again, we're just sketching a graph, so it doesn't have to be perfect, but should be representative of what the graph should look like. So not too much of a stretch there, but here's our graph. And again, that axis of symmetry would be running right through this middle line here. And again, my symmetrical drawings are not the best. We have 1, 0 in this case because it touches the x-axis at 3, 0. So 1, 0. And then finally, the values of x. X can be any real number. So it belongs to the set of real numbers. And y is greater than or equal to 0. And now for our last example of this type here, we have y equals -x² minus 6. So the h value in this case, this could also just be -1 x minus 0 squared minus 6. So we could throw in an h value of 0 if we want. We could throw in a 1 as our a value if we want, but not necessary. So our h value is 0, our k value -6, so our vertex is 0, 6. Our x-intercept is at 0, so x equals 0. Or sorry, our axis of symmetry. Stretch or compression, well, again, we're a 1 here, so there's no stretch or compression. And then a quick sketch of the graph. It's probably a little excessive in size. So a vertex here at 0 and I'm getting a little too excited here. 0 and -6, so maybe down here somewhere. And then we have a parabola opening up like this. Nope, that's completely wrong. That is completely wrong. Well, not completely wrong. The vertex was right that time, but the graph was wrong. It's a negative a value, so the graph should be opening down. So we'd have the graph here, and we should be opening in a downwards direction. That looks a little bit better. So there's my sketch of the graph. There is no zeros. And then the possible values of x and y. X again belongs to the real numbers. And y is less than or equal to -6. So there we have the looking at pulling some information off those equations in a couple different forms. And let's take a look at some more questions here. So what is the equation of a quadratic given that the a value is -3 and the vertex is at -4, -5? So pretty straightforward. If we have our equation ax minus h squared plus k, all we have to do is substitute the appropriate values in. Remember, this here is our h, and this is our k. So if we sub that in, y equals -3 for our a value, x minus h, so x minus, and then I substituted my h value in brackets here because that negative needs to switch, and then plus our k value, which is -5. So I can even sub that in like this. This step is redundant. If you can do it without, that's perfectly fine. We'll just simplify that because that'll just flip the sign on the 4, and then we just put whatever value or whatever sign is on the 5 here. So -3 x plus 4 squared minus 5, that's our equation. And now the next part here, or next question, does 413 lie on the parabola y equals 2x minus 1 squared plus 5? And so I should probably question mark that. This is an x value, and this is a y value. We have an x and a y in our equation. If we sub these values in, all of this over here on this side should equal the 13. So if I sub the 4 in for x, it should equal 13. So let's sub in our values here. 13 equals 2 times 4 minus 1 squared plus 5. Let's calculate that now. 4 minus 1 is going to be 3 squared plus 5. 3 squared is going to give me 9. Two times 9 is going to give me 18. And 18 plus 5 is going to give me 23. These are not equal. Since they are not equal, the point 413 does not lie on the parabola. Okay, so if these numbers end up being equal, then that means that's a point on the parabola. Because they don't equal each other on either side, that means that it is not on parabola. So we're not solving this, we're not rearranging. All we're doing is breaking this in half, putting our y value here, and when we sub in our x value, it should become the same thing. The next part here, we want to find an equation of the parabola with a vertex of 5, -3 that passes through the point 1, negative 8. So we got the vertex, we have our h and k, but we don't have our a value. However, we do have our x and y values, and if we sub all this into an equation, you'll find that we can solve it for a. So y equals, and using our standard form, we have a missing a still, x minus h, in this case minus 5 squared, and then the k part minus 3. So now I can sub in the x and y values. So negative 8 equals a 1 minus 5 squared minus 3. And I can work this out now and find a, because I only have one missing value, which is a. So negative 8 equals a times 1 minus 5 is going to give me negative 4. Negative 4 squared is going to give me 16. Minus 3. Note this is multiplication first. So we got to move the negative 3 over. Negative 8 plus 3 equals, and I'm just going to write that as 16a. Negative 8 plus 3 is going to give me negative 5 equals 16a. Going to move this over here. So we had negative 5 equals 16a. And divide both sides by 16. Negative 5 over 16 equals a. That's our a value. It's going to open down because it's a negative a. And it's also going to widen the graph because it's a number less than 1 when you look at the absolute value. So our equation, y equals our a value, negative 5 over 16. And then we had x minus 5 squared minus 3. So that there is the equation of our parabola. So we can solve these by just subbing in all our values in a lot of cases. Got another question here. Short word problem. A ball is hit into the air. Its height in meters after t seconds is given by the equation height h equals negative 5 times t minus 4 all squared plus 120. Note this is a semi-realistic question in that we have negative 5 is actually close to negative 4.9, which is related to the acceleration due to gravity. So these, when you see these negative 5s in these questions of objects with height and time, that usually means we're approximating an actual physics problem. So we want to find out what the maximum height of the ball was and when does it reach that height. Well, if I just make a little sketch here of my situation. The ball was probably, if we're hitting a ball, we're probably going to be somewhere off the ground. So we're going to start somewhere here off the ground. Doesn't matter where, we're just getting a rough sketch to approximate this. We're going to hit our vertex somewhere, say here, and then an equivalent kind of spacing, maybe somewhere at the end here. We have this parabolic shape. And if this is not the actual path of the ball, this is the height compared to time. Remember, this is the time down here, and this is the height. A ball would follow a parabolic shape if we were doing the horizontal versus the horizontal height versus the vertical height. But in this case, the distance and time are related as well. So the height at any given time is what we have here. And so our vertex here would be at 4 and 120. That would be the peak of the ball. So our vertex is the maximum height of the ball. It's the maximum point or optimum value. So the ball reaches a height of 120 meters in 4 seconds. So we just use our vertex to determine the maximum height and the time that occurs. Now, the next question says, from what height was the ball hit? So like I said, oftentimes we don't have to start on the ground when we're hitting something. If we're playing baseball, the batter's going to generally hit the ball when it's not touching the ground. And that maybe soccer, you would generally hit the ball on the ground, but you get a little Pele style kick and it's up in the air. So things are different depending on the situation. So we can actually determine the height we hit the ball from. If we look at this graph right here, this value, the height h happens at the time of 0. So we can use t equals 0 to determine the height. So we just take h equals -5, 0 minus 4 squared plus 120. And we calculate this. So h equals 0 minus 4 is going to give me -4. If I square that, I'm going to get 16. So I have -5 times 16 plus 120. And -5 times 16, that's going to give me, we got 50 and 30, so 80, -80. So I got -80 plus 120, or the height being 40. So the ball is hit .40 meters off the ground. Now, you think that's crazy if you're assuming this is baseball. You're wrong. It's just someone's hitting a ball in the air. It doesn't give a situation of baseball or whatnot. So someone's just hitting a ball into the air. It might be with a machine. Who knows? Could be a golf ball off a cliff. Who knows what it is? Just some sort of ball is being hit in the air. So they're 40 meters off the ground when they hit it. And then it reaches a maximum height of 120 meters within 4 seconds. Now, 2 other questions here. How high is the ball after 6 seconds? So how high is the ball when we get to somewhere over here at 6 seconds? We want to find out this height here. Well, we can use our equation and let our t equal 6. So t equals 6, and just like the last question, we just sub that in. H equals -5 times 6 6 minus 4 squared plus 120. And then I sub in, and so now that I've subbed in, I just simplify that. 6 minus 4 is going to give me 2. 2 squared is 4. 4 times, and then 4 times 5 is going to give me 20. So -20 plus 120. And collect those together for a height of 100. So the ball is 100 meters off the ground. Now this next question then seems weird. When is the ball 100 meters off the ground? Well, we know it's at 6 seconds, but there's also another time that it's going to be 100 meters off the ground because we have another 100-meter point over here. Sorry. We have another 100-meter point over here, so it's going to hit 100 meters twice. So in order to determine the second situation where the ball is 100 meters off the ground, we're going to switch this around and sub in h equals 100. So 100 equals -5 times t minus 4 squared plus 120. So 100 equals, sorry, let's start simplifying this. 100 minus 120 equals -5 t minus 4 squared. 100 minus 120 is going to give me -20 equals -5 t minus 4 squared. We're going to take that -5, we're going to divide it over here. -20 divided by -5 equals t minus 4 squared. This is going to give me a result of 4 equals t minus 4 squared. Now, the next step is to take the square root. And this is a little tricky because 4, or the square root of 4, there's two numbers that multiply to 4. 2 times 2 multiplies to 4. But as well, 2 times -2 multiplies to 4. So the square root of 4 is actually +2 and -2. It's two possible answers here. So that means this here has to happen twice. So t minus 4 either equals +2 or t minus 4 equals -2. And then we can go about solving these. T equals 2 plus 4. T equals 6. That's our answer from, or that's our situation from before. And also t equals -2 plus 4. T equals 2. And at 2 seconds, the ball is 100 meters off the ground. This square root being a positive and a negative number, and that's what that plus minus means, is positive or -2, so it's two separate pieces that we actually have to break up later on. This is a concept that we're going to be using throughout this, so do be aware that the square roots of numbers are actually the positive and negative result. There's actually two square roots when we're working with quadratics and things like that, and polynomial functions. So do be aware of that. We usually just say the square root of 4 is +2, but this is a very important concept to understand, that -2 squared and 2 squared are both 4. So the square root of 4 could be either one of those answers. Even though your calculator only gives you the single 2, it's also the negative as well. Okay, so some questions you can look at from section 4.4 are numbers 1, D, and H. Number 3, 4, 5, 6, just do A and B. For 6, 8, 9, 10B, and 14. Actually, 13 and 14. 13 and 14. Those would be a good set of questions. So you can use these as some practice problems for this set.